Okay, so we are now on the fourth example, last one. Or if you started with four, maybe it's the first one for you. I don't know. But the fourth example, let's read it and try and talk about what it means. So Craig and Lance are both walking from Oak Park to Casey's, which is 160 meters away. I know Casey's is farther than that. Just bear with me for the example. Craig starts before Lance, so Lance is trying to catch up. Their velocities versus time are given in the graph to the right. So let's look over here, okay? So it says that Craig starts before Lance, and that makes sense because if we look, we see that Craig's velocity begins at 0. So he starts walking right away. Lance's velocity does not begin until 20, so that means Lance isn't moving until 20 seconds have already passed. But we also know that Lance is going a little bit faster. So Lance is going 4 meters per second, while Craig's only going 2 meters per second. So our graph, we should see Lance starting later, but maybe he's going to catch up to Craig and pass him. And I bet you, because I see that this line ends before Craig's, that means Lance is going to stop walking before Craig. So I'll bet you that Lance passes Craig at some point. So down here it says construct Craig and Lance's X versus T graph. Remember to label your axes, include units, plot the points, key, best fit, so on and so on. Now, this says X versus T, so I'm going to go ahead and put T down here. Don't forget to put seconds. I'm going to go ahead and put X up here. Don't forget to put meters, okay? Because they gave us seconds and meters. Okay, let's get rid of all that. That's kind of messy. All right, now we've labeled. Now we have to scale them, okay? So remember, we always just make our time exactly the same. So they counted by 20s every 2 lines. So we're going to go 20, 40, 60, 80. Now we got to figure out what kind of position we want. Now, to me, the telling sign is that it's 160 meters away. Don't get hung up on this 2 and this 4. That's not important yet. That's only going to be important for the slope. So 160, I think that I want 160 somewhere up near the top part of my graph, okay, somewhere in here. And then I know that I've got, put a 0 there and a 0 there. Now I've got 1, 2, 3, 4, 5, 6, 7, 8. Oh man, look at that. Mr. McSparron, you made this so easy. Let's count by 20s. 20, 40, 60, 80, 100, 120, 140, 160. Piece of cake, right? Okay, so now I've got my scale, I've got everything labeled. I'm good and ready to start plotting points. Now here's the tough part, okay? And I really think that it makes things easier to make a table. So I'm going to start off with a table for Craig. Now, I want time on one side and I want position on the other. Now I know one thing, okay? Well, Craig starts off at 0. Okay, so Craig starts off at 0. So at time 0, Craig's position is also 0. Okay, because he starts walking right away. So we're going to go ahead and put well, you know what? Before we do that, let's come up with some more points. Now, 20 is my first time unit, so I'm going to go ahead and I'm going to do 20 here. But here's what we need to know. How far can Craig go in 20 seconds? Well, I know that Craig's velocity is 2 meters per second. So if he can go 2 meters in 1 second, how far can he go in 20 seconds? And all I'm going to do is I'm going to multiply 20 times 2. So I know that he can go 40 meters in 20 seconds. Now the next time interval is 40. And I know that since he could go 40 meters from here to here, he's also going to go 40 meters from here to here, which makes 80. So in another 20 seconds, he travels another 40 meters. And then it's going to follow the pattern. 60, he's going to go another 40 meters, so what's 80 plus 40? 120, that's right. That was like a Blue's Clues thing. I talked to you like you were going to talk back. All right, and then the last one is 80, so what's 120 plus another 40? Well, it's 160, and we see he made it to Casey. So let's plot his position now, okay? So he starts off at 0, 0. Then he goes to 20, 40, 40, 80, 60, 120, 80, 160, and then we draw the line. Okay. Oh, I gotta hurry or this thing's gonna turn off. All right, now let's talk about Lance. Now Lance, he doesn't start at 0. Lance starts at 20 seconds. So we know that he doesn't get going until 20. So at 20 seconds, he's still standing still. Now at 40 seconds, he will have moved. So let's give me a little space to write here, okay? So we know that Lance can go 4 meters in every second. So let's try and figure out after 40 seconds, or after, okay, so this is an increase of 20 seconds. So we can only multiply by 20. So 20 seconds times 4 is going to equal 80 meters. 20 times 4 is 80. So we see that in that first 20 seconds, he goes 80 meters, which makes sense because if he's going twice as fast as Craig, he should go twice as far in that 20 seconds. Now my next time interval is 60, and if I went 80, if I added 80 here, I want to add 80 again, and I get to 160. Now I don't need to go any farther than that because that means he made it to Casey. So let's put him in red. So if he starts at 20 seconds, after 40 seconds, he's made it to 80, and after 60 seconds, he's made it to 160. So let's put Lance's line of best fit on there. Nice. Now, it asked for a key, right? So I'm going to go ahead and write Lance there. And I'm going to write, low battery. Everything's on low battery. Craig there. All right, so now I've made myself a nice graph. I've got labels, I've got good scales, I've got lines of best fit, I've got a key, I've got everything I need. All right, now at what time does Lance pass Craig? Now I think we are all really good at this, and we all know that we want to look for the point where the lines intersect. Now, here's where you're going to get tripped up. Here's where people will miss points. This asks for time. Time is down here, so that means I have to trace straight down. So somebody, I know you're out there, somebody wrote 80 because they went over this way. That's not right. It's not 80. 80 meters is where they cross, but they ask for time. So we're going to say 40 seconds, and then we're going to say that is where the two lines intersect. Perfect. 40 seconds. That's where the two lines intersect. All right, guys, there we go. That's all the videos. Make sure that after you watch a video, you should go ahead and try to practice the second example.